All right, so we've got our second lesson of today, which we're going to look at curve of best fit. So earlier we looked at the line of best fit. So I'm going to share the document here. Um, so we're looking at, does it seem reasonable to draw a line of best fit for relations shown? Oh, it didn't even come through. So sometimes we can't make a line because the points are kind of scattered and all over the place. So we do have to use what's called a curve of best fit. So to draw a curve of best fit, you have to draw a smooth line that passes through as many points as possible. So if we look here at our first example, we are going to draw our curve of best fit. So I'm going to try doing this as best as I can with the computer. So it should be a better line. Okay, so same as line as best fit, you try to have as many points or equal amount of points on both sides of the line. So note if the pattern appears to follow a straight line, the relation is linear. So you would use a line of best fit. So you would use a straight line, but in a case like this one, if the pattern appears to follow a curve, the relation is non-linear. So to make predictions, you would draw a curve of best fit. So exactly like we did here. So you would use a curved line like this, or you follow along the point. So it could be like this, and so on. So I'm going to clear this and I'm going to go to example number 2. So radioactive material decay by emitting particles. The following scatter plot shows the number of particles a radioactive material emits over time. So we're going to do a curve of best fit for this because like I said, it's not linear, so it does more of a curve. Okay, so doing my best that I can here on the computer. Kind of went a little wonky. So do you see a trend with the data? So yes, as time increases, the amount of decay material decreases. Okay, so as time goes on, it decreases more and more, or less, sorry. So is the relation linear or non-linear? So it's definitely not a line. We couldn't use a line. So it would be non-linear. And we should draw a curve of best fit for this one. So if we look here, so how many particles are emitted after 300 seconds? So if we go to 300 here, we go up and over. So it would be about approximately 1700. And we used interpolation for that because it is part of our data. Okay, and I kind of messed up here, so your line should keep going the best that you can. Okay, and then how many particles are emitted after 900 seconds? So if we go back to our graph here, so 900, we would look at our line and it would be approximately 900. I'm typing it here and I'm not going down because I don't want to lose our graph. And because it's outside of our data, so our very last point is at about 800. So that would be extrapolation in that case. So I'm going to clear this so I can show you your work real quick. Okay, so here they drew the curve for you. So you just have to answer the questions that go along with it. And then here you would do your own. So again, you can do it on paper, on the website that I gave you, or you can use something like Paint. And that's it.